All right, in this video, I'm going to be reviewing how we find inverses of logs or inverses involving log functions. So we're going to find the inverse of each of the following. Before I jump into this, a quick reminder is the idea of inverses as they pertain to logs. The big idea is if you have some exponent or some base raised to an exponent, notice how the base here is the same as the base there. Logs and exponents, or exponential functions, are inverse operations. So when that happens, those undo each other, or they cancel each other out, and you just get x. Same thing over here. If we start with a log function with a base b, but we're taking log of some exponent with it also a base b. Notice the bases are the same. Those are inverses of each other, so you just get x. That idea is going to be the premise of how we can go through these problems. So, if I want to find the inverse of the following functions, this left one, we have y equals log base 2 of x. The first and probably most important step of finding inverses of functions is we're going to switch x and y. So instead we're going to have x equals log base 2 of y. So now that we switch x and y, the idea is we would like to get our y all by itself. So we want to get y all alone. Right now I have this log base 2 here. I would like to get rid of this log base 2. And how we get rid of a log is we're going to use ideas of inverses up here. So we got rid of logs twice by either having 2 raised, the same base raised to the log exponent, or a log base and then exponent there. So if I want to get rid of a log, I'm going to need a base exponent. So here's what I'm going to do. Both sides are now going to become exponents. It's hard to see here, but here's what's going on. I'm going to take each side and make it a base 2 and raise it to these exponents. So we have is 2 raised to the x equals 2 raised to the log base 2 of y. So I took both sides and made them raised to the power, raised from the base of 2. The reason why that's important is over here we have a base of 2 and we have a log of base of 2. So base of 2, base of 2. Since the bases are the same, properties of inverses with logs says that is canceled out. So we have y equals 2 to the x. I look to see is there anything else I can do over here to try and get y by itself. Well, it's all alone, so we are done. That would be the inverse of this original function, y equals 2 raised to the x. So that was a pretty basic problem, but again, this idea of using inverse properties there is important. So let's look at another one. This one's going to be a little bit more complex. We have y equals 5 raised to the x minus 9. So again, first step of inverses is we're going to have x equals 5 raised to the y minus 9. So x and y switch places. So again, my goal is to try and get y by itself. So I have this base of 5 raised to the y and a minus 9. So since I'm solving for y here, I'm doing an order of operations backwards. So I'm going to get rid of this minus 9 by adding 9 to both sides. So that's going to give me x plus 9 equals 5 raised to the y. Still got to get that y by itself, so I have this base of 5. So again, if I think back, how do I get rid of a base? What we're going to use is logs. If you want to get rid of a base, b, you take the log of b. So what I'm going to do is I'm going to take this right side, take it log to the 5th. If I do it to one side, I got to do it to the other side. So I'm taking both sides log base 5. So how that all looks out, looks like log base 5 of x plus 9 is equal to log base 5 of 5 raised to the y. Now what happens here that helps us out is, again, like I talked about those inverse properties. I have a log base 5 and I have an exponent here with a base of 5. Since those bases are the same, those are inverse properties. So on the right side I just get my y, which is what I wanted. On the left side I get my log base 5 of x plus 9. That has y all by itself, so you would be done. One more point I'm going to make on these problems. So this is the mathematical reasoning behind how all this is going. But with these problems, another way you could think of it, so this one over here we had x equals log base 2y. And say, another way that this might help you on the test is we get stuck here. Well, we're currently in log form, so the kind of the rule of thumb is if we're in log form, what I would do is switch everything to exponential form. And if you're in exponential form, we're going to switch everything to log form. So this is just another way of thinking of things that might help some of you. So I'm kind of stuck. I don't know what to do with a log. I don't remember the property. So if you switch things over to exponential form, well, think of bacon and eggs, and you can watch the video on switch between logs and exponents. If you switch this back to exponential form, because we're currently in log form, you'll get 2 raised to the x equals y, which you'll notice this is the exact same thing we got up there. So we're in log form, switch to exponents, it gets you y by itself. Same idea can apply this one over here. You know, we had at one point x plus 9 equals 5 raised to the y. So you're like, well, I'm not really sure how to get y by itself. I'm stuck. Since we're in exponential form, because we have exponents, let's switch to log form. So you can think of bacon and eggs, bay, whatever. So I need a base first, answer second, and this is equal to my eggs or my exponent, which was y. So switching from exponential form to log form, look, all of a sudden I'm now also in y equals y by itself, so it works. So that's just another way you can think of things, but again, this up here is the reason why we talked about inverses and the reason why it works.